The continent of Europe contains the largest and most diverse group of academic and scientific researchers in the world. Collectively, Europe's research community is producing terabytes of important data every day. Thanks to a collaboration between the European Commission and nearly 30 national research and education networks across Europe, scientists can share and distribute research data using the fastest, most advanced network of its kind in the world, GÉANT. GÉANT, the pan-European multi-gigabit research network, is creating the biggest interconnected community of scientists and academics in the world today. As we shall see, GÉANT is a great success story of European cooperation. It delivers exciting benefits to its users and will play an important role in shaping the future of European science.
The benefit of having GÉANT at the pan-European scale now is first to have a very high quality network with a lot of bandwidth available for any usage, but also to make possible new aspects of science which would not be possible without these broadband communication networks.
It must be the case that the network is changing the way research is done across Europe. Right now, researchers can act as if they're in the same room when in fact they're an entire continent away. The network also enables them to patch together computing facilities from various countries around Europe as if they're one large computing system.
In this video, we will look briefly at several diverse European research groups who are relying on GÉANT for the future success of their projects. GÉANT is literally changing the way they do science.
We're interested in trying to design things so that they stand up in earthquakes, so they don't collapse, kill people, damage economies. GÉANT is transforming the way in which we look at our research. It's enabling us to look at full-scale structures to understand how real structures behave in detail. It's also enabling us to share our information across multidisciplinary research groups, which we've not been able to do effectively. And in the longer term, I think it will help us interact more effectively with industry, so the benefits of our research will have a greater impact on society in the longer term.
Operational since 2001, GÉANT is the pan-European backbone that provides links at speeds of up to 10 gigabits per second between the national research and education networks, known as NRENs, in different countries across Europe. Together, GÉANT and the NRENs provide Europe's research and education community with the fastest, most sophisticated network services available anywhere in the world today. The NRENs contribute more than 50% of the cost of GÉANT, the remainder being funded by the European Commission. To image the most distant parts of the universe, radio astronomers use a technique known as Very Long Baseline Interferometry, or VLBI. VLBI links several telescopes together and uses the distance between them, sometimes thousands of kilometers, to create a single instrument with a resolution many times that of any telescope ever built.
Radio astronomy is very hungry for data, especially high data rates. What we're trying to test with the GÉANT network is the possibility of doing real-time VLBI. So that means that we don't use tapes to transfer the data, but we use the optical fibre network that's provided by GÉANT to transfer the data. Without GÉANT, then I think we'll be very limited on the type of science that we can do. We'll be able to do what we do at the moment, but we want to go way beyond that. As GÉANT develops over the next few years, the next few decades, that'll allow us to collect more and more of the data that comes across space and is collected by the telescopes. And that'll mean we'll be able to detect sources which are right at the edge of the universe, galaxies that are just forming, stars that are exploding. It gives a whole range of new opportunities for VLBI.
The institutions of the EU have long recognized the benefits pan-European networks can bring to the advancement of research. The European Commission believes that state-of-the-art research networking is fundamental to maintaining European competitiveness.
I think that we couldn't actually think about European research area without having this kind of high-speed network available at the same time. To do research together requires that research results can be shared at the same time anywhere in Europe. I'm sure that this is one of the biggest steps where we have been able to move very fast.
Museums have often had a rather low-tech image. In fact, that's changing quite radically, and we may very well see taxonomy, the science of classification, turning into an information science. And that's largely happening through these very fast network connections and the power of computing. GÉANT, with its high-speed connectivity, will improve the basis of taxonomy through better communication, better access to images of specimens, better access to data, better access to databases, which are currently being built at quite a large scale across Europe. So GÉANT is absolutely essential to the future of turning taxonomy into an information science.
Accurate models of the way that the many components of the Earth's climate interact are vital to answering urgent questions about the impact human activity may be having on climate change. Many centres across Europe are producing climate models that look at different components of weather systems. But to get a full picture of how they all interact to influence the world's climate, they need to be compared and run together using distributed computing. At the Max Planck Institute for Meteorology in Hamburg, Dr. Reinhard Budich is running a project called PRISM, the Programme for Integrated Earth System Modelling. PRISM is developing an infrastructure of people and technologies comprising 22 partners from research and industry to facilitate the comparative analysis of models using standardized protocols.
When we talk about Earth system modeling, we know that we have to have as many component models and as many processes involved as we can, basically, because we know that the feedbacks between these different components influence very much how the Earth system is evolving. The amount of data that we produce with a complete Earth system model is in an order of magnitude that makes it difficult to transfer over the network. Thanks to GÉANT, this possibility is now emerging and becoming more and more important. We here at the German Climate Compute Center produce about 100 terabyte a month, and we have about a petabyte stored this year here. And a lot of this data has to be exchanged with the rest of the world, and that shows how important networking is for us. We use GÉANT, but we don't see it, but this is very good because it proves that GÉANT is very reliable in a way. If we would see it, it would probably mean that it would break down somewhere.
We're all doing similar sorts of work in many ways, and there's a lot that we can learn from particle physics community, for example, and there's a lot that they can learn from us in the way in which we're handling data in generic ways.
GÉANT is just mission critical to particle physics. I can't put it more succinctly than that. Without it, we are just not in business. Because of the massive amounts of data we're producing, we need GÉANT to provide 10 gigabit connections between the major centres, CERN, major centres in Europe, and of course the connections to the US, the transatlantic connections.
It's going to underpin the way in which all research is done in the future, and the sooner people get into it and start to understand how to use it to their best interests, the better for everybody, I think.